Hello, everybody, and welcome to our Tuesday, April 14 PDP Dairy Signal. We're excited to bring a great topic to you today about ventilation systems. We recognize it's the middle of April. It's what we call spring here in Wisconsin and the Midwest. But the heat of summer will be upon us before we know it. We're going to dive in deep to talk about some important things we need to know for our dairy cattle. Before we get involved in the episode for today, I want to say thank you to our national sponsors. They walk beside us every day and help us bring quality programming to all of our members day after day, all year long. And we couldn't do programming like this without them. I also want to say a special shout out to our monthly sponsor of this program, DLF. DLF, I've got some talking points here, so I'm going to divert my eyes to the talking points here. Just want to tell you a little bit about DLF. They're a global leader in forage seed research, development, production, and distribution. They've been developing and promoting improved forage seed products for over 150 years. They're the seventh largest seed company in the world. They supply seed to over 100 countries. They're owned by 2,500 growers, and they strategically place seed production, manufacturing, and distribution hubs in places where they can be easily accessed. Thank you, DLF, for supporting our Dairy Signal episodes for the month of April. We appreciate it very much. Before we dive in, I've got a couple of things I want all of our listeners to know. If you're listening live today, you have an opportunity to interact with us and to make this program yours. I'll shortly introduce our presenter to you, but we want you to ask your questions. And the way that you'll do that is when you're watching on a desktop monitor, there'll be a place in the lower right-hand corner where you can enter a question. It will give you an opportunity to also put your name in there. You don't have to enter your name, but you can ask a question and then hit submit, and then I'll see your question pop up on my screen. And when appropriate, I'll make sure to ask that question of our presenter. The other thing I want to remind you of is that every single episode is accredited by DACE, Dairy Advanced Continuing Education Programs. So if you're one of the many who track their continuing education credits, you'll have an opportunity to do that at the end of the episode. We'll present you with a simple quiz just to prove that you are listening to the content today. You'll answer the questions on the quiz and then just click submit. And once we get your quiz answers, we'll make sure you get the continuing education credits you have coming to you. So very simple and effective way to participate in the program today. All that being said, I would like to turn this program over to our presenter for today. She is Nestle Octanez. She's assistant professor and extension specialist at Biological Systems Engineering at the University of Wisconsin-Madison, where she is presenting to us today. Nestle, I'm going to turn the program over to you. Could you start by giving us a little bit more information on your background and why is it that this topic is of interest to you? Take it away, Nestle.
Thank you very much, Shelley. Good afternoon, everyone, and thank you for the introduction. I am Nestle Akdeniz. As you mentioned, I'm an assistant professor and extension specialist in biological systems engineering. So I am on campus, on Madison campus today. I am in my office. This is Henry Mall. It's one of those historical buildings if you ever have a chance to visit. So I got my PhD from Iowa State. I was a postdoc at the University of Minnesota. Then I was a clinical assistant professor at the University of Illinois, Urbana-Champaign, UIUC. So I was always involved in livestock, building design, structural engineering, ventilation design. Then in 2022, I moved to Wisconsin and I started to work with dairy producers. I learned more about ventilation design, building design. So now I am into dairy ventilation design. But as an engineer, I try to take a little bit different approach. And I'm not looking at it from animal response side. I'm much more like looking into it from engineering perspective. And today we will talk about energy efficient ventilation design and what are the things we can do to save money? What are the things we can do to make this work a little bit better? All right, so without further ado, let's get started. So a little bit background information. So we always hear about heat stress, and then it really depends on where we are located, right? So is it really happening? How severe this problem is? How many days in 1 year do we have that we need to worry about heat stress? So we are talking about our lactating cows, right? So I digged into data. So there is an index called temperature humidity index, right? We are all familiar with this index. So it is not the only index we can use to assess heat stress, but it is commonly used since it is easy to measure, right? So I looked at the data. So I scanned last 5, 6 years data, and it really depends on where you're located, right? So if you're a little bit like inside the Wisconsin, if you are in the southern part of Wisconsin, it's different. It's a different climate. If you are central or northern Wisconsin, it's a little bit cooler. But as an example for this slide, I pulled together data for Madison. So on average, in Madison area or in southern Wisconsin area, we have 25 days of severe heat stress. This is average. We never know what will happen, right? This is average. And we have more than 5 days of very severe heat stress days in 1 year. So one fun fact or interesting thing this year, we had all these up and downs, right? We had those very warm days in February. We were wearing short sleeves. And then we had the snowstorms, right? So up and downs. But what data shows us by the end of March, so we are counting January, February, and March, we had 2 mild discomfort days and 1 discomfort day. So this year we already had mild heat stress days. It's nothing maybe very severe heat stress, but we did have some heat stress days in winter. So it does happen. We don't know what weather will bring, but we know summer will come, and now is the good time to start thinking about summer ventilation design and getting ready for the summer. All right, so what are the impacts of heat stress, right? A little bit background information. So as you know, there are short-term impacts and they are not permanent, and long-term impacts. Hopefully it is never that much severe that we don't see those long-term impacts. But the short-term impacts, I think the first thing is reduced feed intake, right? And then animals don't want to sit down, increase standing time, bunching behavior, and reduce production, right? These are the things we can see when it gets a little bit warm in summer. And any kind of stress, right? Heat stress, cold stress, or any kind of stress increases the animal's susceptibility to diseases, right? Something that we don't want to happen. All right, so ventilation is one way, one approach to mitigate heat stress, right? So it is one of the main approaches. So when we think about ventilation design, when we think about the dairy buildings, the ones that I saw in Wisconsin, there are usually 3 options. So they can be naturally ventilated, Usually there are circulation fans inside these naturally ventilated buildings, right? And then when it gets very warm in summer and when the wind speed goes down, then there are sprinkles, right? They support the ventilation system. So they can be tunnel ventilated. Tunnel ventilation also comes with circulation fans. So those, we sometimes call them pushers, right? So all those pushers push the air in one direction, and those mechanical tunnel ventilation fans, they pull the air. So air moves in one direction, and we call it tunnel effect, right? Chilling effect. It can be cross-ventilated, so we will look at an example of cross-ventilation. Cross-ventilation usually comes with baffles, and baffles are good since they're very energy efficient, right? We don't spend any energy for baffles. It's a matter of installing them and maintaining them. Okay, so here we are looking at an example of natural ventilation. Right, so we see the sidewall curtains. Usually there are two pieces, right? 6 feet, 6 feet. Sometimes they overlap a little bit. So we see the higher the roof, the better in natural ventilation. Since hot air goes up, if the roof is high, it will create that pressure difference. So air will move easily. So rich openings in Wisconsin, sometimes naturally ventilated buildings, all those rich vents are closed since there's a lot of precipitation coming in, right? And then it makes the feed alley wet and we don't want it. So if the rich vents are closed, then it is not the, traditional naturally ventilated building. It is a hybrid design, right? It is in between natural ventilation and mechanical ventilation. And then for natural ventilation, to make it work, we need to make sure that there are no obstacles around the building, right? So the building is able to get all the natural width. So we don't have to have mechanical ventilation. So we don't have to install those mechanical ventilation fans. I have seen farms, I have seen buildings, they are naturally ventilated and it works perfectly for them, right? So there's no problem with that. And when you enter the building, it's very bright, it's very quiet, right? There are no of those ventilation fans. So it's a very nice environment. But usually they are located in a place like shown, somewhere like shown in this picture, right? So there is nothing around those buildings. So they are able to get that wind. So we say like in the Midwest, it depends where you're located, but in the Midwest, wind blows from west, right? Either northwest or southwest. So if we are able to capture that wind, then natural ventilation can work for your building. And that is okay. But if you're not able to catch the wind, let's look at this example on the right-hand side. So assume that you're trying to ventilate that building in the middle, right? It is surrounded by other buildings. So the business is growing, the farm is growing, you keep adding new buildings, then you may not be able to catch the natural wind. Then you may want to add some mechanical ventilation fans. So it is one, right? We are worried about wind shadows around the building. Another one is the larger the barn gets, the harder it becomes to aerate, right? So if you are talking about 4 rows, it's easy, but 6 rows is harder. Maybe 8 rows, even it's harder, right? So if the building is getting bigger, if we are adding more rows, then we may need to start thinking about mechanical ventilation. So this is an example of tunnel ventilation. So these are my CFD drawings. So this is a simulation software we use to demonstrate how the air flows inside a building. So you see the air inlet and you see the ventilation fans on the other side, and air moves perpendicular to the stalls, right? So, and as you see, there are some circulation fans, pushers. They also help air move. So the goal is not to aerate the feed alley, right? The goal is aerate where the animals are located, to aerate the stalls. And circulation fans help with that circulating the air. They don't bring in fresh air from outside, but they circulate the air inside the building. So this is an example of cross ventilation. Again, there's this air inlet, right? One big opening on one side, and there are ventilation fans. These are exhaust fans, so they're pulling the air through. So on the other side. So tunnel ventilation, they are usually rectangle shaped buildings. Cross ventilation, they are much more like square shaped buildings, right? And then here you see the baffles, right? So how they help when the air comes and hits to the baffle, that baffle pushes air down. So we don't want to aerate the ceiling area, right? So we want to aerate where the animals are located. So it increases the air speed at the animal level. So baffles, they are difficult to them clean, especially if they are white. They show dirt, they get dirty easily. But I really like the baffle idea since they help. And it's not like circulation fan. You don't consume any electricity. All right, so now we covered the basics, right? Natural ventilation, and then sometimes natural ventilation may not work. We may need to switch from natural to mechanical ventilation, and we may decide to buy some fans, right? So question number one, how do we choose the fan? There are so many companies, there are so many options. They're all good, but how do we choose the best option for us, for our farm, right? So one thing that we can look at is the fan efficiency. It's very important since if it is not a good, fan, if it's not an efficient fan, it may increase your operational costs very significantly. Okay, so we are going to look at the fan efficiency. So there is a lab in Illinois, in Champaign, on that campus. It's a certified lab, and they test these agricultural fans. Okay, so they provide you a report, and this report looks like something like this. So we see the fan efficiencies at varying static pressure. So what is a static pressure? Static pressure, the definition might be different, but you can think of it as anything that is resisting to airflow. So we have the animals, we have the stalls, right? Those exhaust fans are trying to pull the air. So the driving force is the static pressure, but as the static pressure goes up, efficiency goes down. Then fans are not able to draw air that easily. It's difficult, right? So they're working. If static pressure is too high, then they may not work very efficiently. So static pressure is never zero, right? There is some static pressure inside the dairy building. What is the static pressure? So if you never measured, a good guess would be 0.05, 0.1, or 0.15 for their building. So it is not that close or very tightly closed environment, right? It's kind of open. So there is some static pressure, but it wouldn't be too high. So we are going to look at the fan efficiency at 0.05 or 0.1 static pressure. And fan efficiency is like the unit is CFM per watt. CFM is the airflow, right? How much air we are flowing and how much energy we are spending. So efficiency is to be able to move that much of air, how much electricity we need to spend. Okay. Okay, so we understand fan efficiency is important, right? And now when I look at this report, I see some numbers, right? 24, 21, 19, 16. So what do they tell me? What is a good number? What is a bad number? What's the number am I looking at, right? So to be able to answer this question, so we looked at the records from 2015 to 2025 and calculated some average numbers. Okay, so now we know the average, right? Whatever fan is available in the market, what is the average? It depends on the size of the fan. So we group the fans in different sizes, right? And looked at the average. And then we looked at the upper limit and we looked at the lower limit. So now we have that threshold, right? We know what number we are looking for. So this study was published. So I have a small QR code here if you would like to scan and have a look, but I will quickly introduce you the results. So we developed the interactive tool. So if you go.wisc.edu/coolfans, so go.wisc.edu/coolfans, you will see this tool. So if you want to see it in SI units, there's in SI units, it's also available. So it is go.wisc.edu/coolfans.si. So you will see this tool. So you can enter the static pressure. So this is one thing that we will get from BestLab, or we are going to ask that fan company. Each fan company will be able to provide you a report, fan efficiency report. Okay, so then we are able to enter the fan efficiencies and it will give us a graph like this. So here we see the average. So average is the green line, okay? And then we see the low. Low is this dashed line, dot is red dots. And then we see the high. High is the dashed line. And then we will see the user fan. User fan, those are the stars, okay? And then here you're able to pick up the fan size. So it can be a 36-inch fan, 48-inch fan, or 60-inch fan, whatever fan you're planning to purchase, okay? So let's look at an example, okay? So this is the BestLab report. These are real fans, so I didn't make up the numbers. So these are the CFM watts, right? Fan efficiencies we see here. All right. So I'm assuming it followed me, right, Shelly?
Yes.
All right. So here is the tool. When you go.wisc.edu/coolfans, and then you will see the pressure, right? So these numbers are kind of constant since they are provided by those certified labs. And then we are going to go ahead and enter our numbers. Okay, so this is one example that I already entered, and it shows me this line. Okay, so the stars. Let's say we are working at 0.05 static pressure. So it is above the higher level, right? High threshold. So if our static pressure is 0.05, or if our static pressure is zero point 0.1, this is a very good fan. So this fan has a fan efficiency higher than most of the fans that are available in the market. So we may want to choose this one. This is a good one. But if we are working at a higher static pressure, let's say it usually doesn't happen in dairy buildings, like we are talking about free stalls, tie stalls. It usually doesn't happen. But for a reason, if our static pressure is as high as 0.25, then fan efficiency goes down very significantly. Now we are below that lower threshold, right? So this is a fan that is good for low static pressure. Let's look at another example. So I have some numbers in front of me. I will go ahead and enter them. So you see my line is changing, right? Okay, so this is another fan. This is another best lab report, or this is another certified lab report, right? So if let's say our static pressure is zero point 0.1, we are within the average. So it is not a superior fan anymore. It is within the average. It is still good, right? It's not bad. It's still good, but not like above the higher threshold, right? So if static pressure increases like 0.15, so it's getting better and better. So this is a fan designed to work at higher static pressure. So if your static pressure inside your building is higher, then you may want to choose this fan. So it all depends. Okay. So let's look at another example. So I was working with 60-inch fans. Now let's look at the 48-inch. So I'm able to choose any of these. Okay. So let me enter a 48-inch fan efficiency. Okay. So now we are below the average at any static pressure for this fan. So it is not below that red dot, so it is not below the lower threshold, but we are a little bit lower than the average. So not bad, but may not be the best option, right? So looking at another example. Oh, I missed one. Ah. So when I refresh my website, it will just go back to original. Sorry. I entered it at the wrong location. Okay, so this is another option. And this fan, static pressure is always above average. So no matter, the efficiency is always about average, no matter what the static pressure is. So this is a good fan that we may want to choose since it is kind of independent of the static pressure and it is always above average. So it really depends, okay? So if we scroll down this tool, there is another graph here you can see. So you see the fan 1, fan 2. So one thing that we know is bigger fans are always more efficient, right? The bigger the fan, the better it gets. Smaller fans, they need to work very hard to pull air through, right? So they are less efficient. But bigger fans are more efficient, but they are more expensive, right? But maybe we don't need that many of fans. Maybe you can just buy 4 fans and pull enough air. If it's a smaller fan, you may need to buy maybe 8 of them, 9 of them, more of them, right? So that you pull the same amount of air. Here's an example. We see fan 1 and fan 2. So I entered some numbers as an example. Let's say fan 1 is a big fan, and according to our calculations, we need 4 of them. Okay. And then I made up a cost. I think for a big fan, 2000, 2500, they are good numbers, realistic numbers. And then the capacity. I assume this is a variable speed fan, and in summer it works full speed. Okay, so 27,600. And then efficiency at that capacity from the report I will be provided is 22.8. And then in winter, I reduce the capacity. A big fan doesn't need to work that hard when it gets warm, right? We can just reduce the capacity. I entered the cool weather capacity and efficiency. For fan 2, this is also another fan from you can find on the website. So I assumed we need 9 of them since they need to pull equal amount of air, right? Equal amount of air exchange. And then this is a smaller fan, so it is less expensive, it's cheaper, 500. And the capacity, efficiency, cool weather, and warm weather. So when we look at that, all these information, we see that expensive but more efficient fan pays back in 4 years. So 4 years later, you will start saving money. Although the initial purchase cost is more expensive, it does catch up at some point. It does pay back. Okay. So I have another example. Let's enter some other numbers. So now we are thinking about smaller fans. Their efficiencies are lower. So I assume that we just turn off these fan in winter. So 0. Okay. And then fan 2. So the purchasing cost is a little bit different, and then the capacity is a bit different, and efficiency is a little bit different. So here we see that fan 1 and fan 2, they never overlap, right? So the expensive fan, it never catches the less expensive fan, although it is more efficient. So this tool is also available here and we can help you with the calculations. So it doesn't mean that a fan is more efficient in a reasonable period of time, it will pay back. It depends how much we see the difference. Okay. So let's go back our presentation and look at more information. So one thing that the lab report provides is the SI unit. So if you're ever interested in using SI units, you can just get the information from SI unit table and plug it into the SI unit calculator. But the version we used, we talked about CFM per watt, right? So that version is the one we are more familiar with. Okay, so we said bigger fans are more efficient. This is something we knew from the beginning, right? But there are a couple of things we need to consider, right? So number one is the variable speed fan. So we don't want to buy a very big fan that we cannot adjust the speed when it starts cooling down, right? In summer it's good, but in spring, in fall, we want to reduce speed. Even in winter, maybe we don't want like zero airflow rate, right? We want a little bit air coming in. So variable speed fans are better, are always better. So if we are buying a very big fan, we are looking at variable speed fans. If it's a small fan, that is okay. We can just turn it off, turn it on. The number of fans will change, so we can adjust the airflow rate. But if it's a very big fan, we want it to be a variable speed fan. So another thing is we don't want to have one big fan, right? Where are we going to put it? So it will never provide us an even airflow distribution, right? So we want like 3 fans, 4 fans, 5 fans minimum. So if the calculations show us that we need only one fan, we may want to reduce the fan size so that we don't put only one fan or only 2 fans, right? We want to have a couple of fans so they pull the air through and we have an even air distribution. So another thing we need to consider is, this is very important, is there enough wall space? Sometimes there is that garage door, right? Sometimes there is that door, and sometimes there is a feed bin outside. So we need to somehow install these fans on the wall. And depends on how much wall space we have, may want to adjust the size. We may want to have like 5 73-inch fans, and then we may want to have like 8 48-inch fans. So variable speed fans at different sizes, we may want to adjust it. So these are the things that we need to consider when we are buying a fan. So the bigger is more efficient, but there are other things we need to worry about. Okay, so another thing that we know is fans are more efficient if they are not operating at full capacity. So we don't want the fan run at full capacity. It's kind of like a car, right? We don't want to go full speed. It's not the most efficient way, right? So reduce capacity. So, okay, we know reduce capacity, but what is the reduced capacity? So our data show that it depends. It really depends on the type of the fan. But as in general, 85% capacity is the most efficient capacity. After 85, sometimes it goes up, but mostly it goes down. So once we reduce capacity more, then it's not that efficient anymore. So our target is 85% capacity maximum. Okay, so we talked about fans. What's the right fan, right? And now how many of them do we need? There is another tool, and the website is go.wisc.edu/coolcows. So it will give you the number of fans you need for your facility. So it looks like this. So this is much easier to use. So the first step is to choose your location. So if you are located in Wisconsin, you can choose southern or central or northern, since there are basically two climates. So southern is a little bit warmer, maybe northern part of Illinois, maybe Iowa, close to those climates. And the central and northern part, they're a little bit cooler, so maybe they are closer to Minnesota climate. But if you are using this tool, and if you're not located in Wisconsin or like nearby states, you can still use. The only difference will be, so it will give you the number of fans you need. When it's calculating the energy consumption, the number of hours this fan needs to work in 1 year, it may vary. So that part will be different. Okay, so we select a location. Then it's very easy. We enter the dimensions, right? So barn length, height, and width. So if you are confused, like what was the ridge height, sidewall height, there's a little bit a small schematic here. It shows you the height. So the next step is number of cows. This is also easy, right? We just enter the number of cows. Then the air exchange rate, the target air exchange rate. For lactating cows in summer, we say 60 air exchanges per hour. So buy our fans, we do our ventilation design for summer, right? And in winter, we just reduce our capacity. Either we use variable speed fan, or what we do is we just turn off some of the fans, and some of the fans are still running. So in winter, we only need 4 air exchanges per hour. And in the parlor area, usually these are busy areas, right? High car traffic areas. We want 60 to 90 air exchanges per hour. And then a fan capacity, fan price, we can find this information from website, or we can ask those fan companies, they will provide. And then fan efficiency, we talked about BESLAB at our static pressure. We never look at the fan efficiency at zero static pressure. We will assume 0.05 or 0.1, and we will look at the corresponding number. Okay. And then it does calculate. It's kind of like an Excel sheet. So one thing it will calculate is number of fans required. So how many fans do we need to be able to achieve 60 air exchanges at that capacity? Another thing that is very important, it will calculate is the required inlet size. So when I visit a farm, most of the time I see that buildings, they don't have enough air inlets. So the inlet is very small. So fans are trying to work, right? But there isn't enough fresh air coming in. So they need to work very hard. So they're having a hard time. And it is something that reduces fan efficiency very significantly. So you're paying for the electricity, you have the fan, but it's not pulling enough air. So it is very, very important to check you have enough air inlet size. Your air inlet size is big enough. Okay. So, and then it will also calculate the annual energy use per head only if you're located in Wisconsin or a similar climate. So if you're located in a much more southern state, this energy use may change. But the required air inlet size and number of fans, you can still use the calculator. So no problem with those. Okay, so the second version of this fan is you already have a mechanical ventilation system. Okay, you already have the fans. Let's say in this example, you have 16 fans and you have already have these numbers. Then you can test what is the air exchange rate you're achieving with the number of fans you have in your hand and what is the required inlet size. So you can just go ahead and measure your inlet. And if it is a number smaller than this one, if it is much smaller than this one, then your fans are having difficult time. So they are not working efficiently, right? They are working actually very hard, but not able to pull the air through. So inlet size is important. So it is one of the first things I measure. Most of the time, we don't have enough inlet. So it's very important to keep in mind. All right, so other things that we may want to worry about is there are some low airflow zones inside each building, right? This might be a holding pen, right? It's kind of high traffic area. It's kind of on the side of the building. So it's the place we may want to add a little bit more circulation fans to make sure there is some fresh air going there, right? So there's some air circulation. Or there might be even wind shadows inside the building. We talked about wind shadows outside of the building, but inside of the building, for example, if you have one of these robots, right, depending on where they are located, sometimes we have to put them where we can, right? We don't have a chance to choose. So depending on where they are located, they may be causing a wind shadow inside the building. So they may be kind of blocking the incoming air. So then we may want to add some more circulation fans to make sure animals are not getting too warm, especially in this commitment pen. Since if they're getting too warm, one, like due to heat stress, their production will go down. Another thing is they will be less willing to visit these robots and then production will go down again. So there will be two factors that are affecting the production. Okay, so another concern when I see one of these barns that are connected to each other, right? So if there's a parlor that is connected to the barn, so I understand it is easy like that, right? Animals just go to the parlor, but it does affect the airflow rate. So in literature, they sometimes say if they're horizontal, they say this is the T shape. If they are vertical, they say the H shape. So depending on the design, the connection areas will have very low airflow rate. Those are the parts that we may want to add more circulation fans to make sure the air keeps going. Okay, so we talked about heat stress, we talked about ventilation design, right? Natural ventilation, mechanical ventilation, how to choose the right fan, how to look at the best lab report. And then once we choose the fan, how to calculate how many fans we need, what is the required air inlet size, right? But ventilation is not just about heat stress. Ventilation is more than heat stress, right? There are some air quality concerns. So in summer, ventilation is designed to mitigate heat stress. In winter, ventilation is for maintaining the air quality. So in summer, we don't have air quality concerns since ventilation rates are high. We have enough air exchange. Usually air quality is okay. But in winter, we reduce the ventilation rates. Heat stress is not a concern anymore. Then we have air quality concerns. And when you're buying a fan, please think about the noise of the fan, right? There are different specifications. And when you're choosing a ventilation design, think about the light. So let's look at a couple of more slides here before we wrap up. So usually sand bedding is very good, right? It doesn't generate a lot of odors, gases. But if you have a calving pan, or if you're housing our cows inside, if you're using straw bedding, it's a significant source of airborne emissions. So we may have some ammonia problem. There might be some other gases coming out. So it's a matter of managing the air quality, ventilation design, and bedding. So noise level, I checked many fans. So one number that we need to keep in mind is prolonged exposure. So I'm not talking about short term, but this fan keeps running. And if it is generating noise more than 85 decibel, then it may cause some hearing damage. So fortunately, the fans we use, they're not that loud. So circulation fans are much lower than the threshold, like supply fans are lower. Some very, very high capacity, like very big fans might be very loud. So if you're planning to purchase one of those fans, you may want to check the specifications. Usually producers, they give you that decibel number, so you need to keep an eye on that number. And then ventilation design is also related to amount of light that comes inside the building. So our goal is 200 lux, which is a very low number. So I think in my office, I have like 300, 400 lux right now. So we want 200 lux at cov level. So if it's a naturally ventilated building with rich vent, rich opening, right, naturally light comes in and we never have a problem. You may want to turn off your lights if it is naturally ventilated building. In cross-ventilated buildings, when we use the baffles, especially if these baffles are not transparent baffles, and once they get dirty, they may block the light coming inside the building. It is one thing that we need to keep in mind. Okay, so this is kind of summary table. So what I did in this study, I looked at the number of days. So anytime temperature is lower than 4.4 degrees C, we call it a winter day. Okay. Anytime temperature is above 20 degrees C, we call it a summer day. So in winter, our goal is 4 air exchanges per hour. In summer, our goal is 6 air exchanges per hour. And in between is kind of transitional phase, right? We want that incremental change. So based on my calculations, the minimum cost, since here we like achieved exactly four air exchanges or 6 air exchanges. In real life, we don't achieve exact numbers, right? We just come close to these numbers. So minimum cost, if you're a little bit like southern part of Wisconsin, is $57 per head for ventilation. I'm talking about only the ventilation fans. If you want to add the circulation fans, then the cost goes up. If you're a central Wisconsin or northern Wisconsin, a little bit cooler region, then it's $52 per head. So this is the annual cost. So if you have 300 animals, you need to multiply this number by 300. So it is a significant cost. So we check the purchasing cost, right? And then we understand ventilation fans, they consume electricity, so they increase the operational cost. So we do our best to lower these, by choosing high efficient fan, we lower these operational costs. And then if you're ever planning to purchase fans, you may need to upgrade your system, right? If you want to transition from phase 1 to phase 3, since you're adding more fans into your barn, then it will add up to the cost. So just be aware, it might be a hidden cost when you're purchasing more ventilation fans. And then it is kind of my summary slide. So as we are getting ready for summer, so one, please clean your fence and shutters, right? If the fence are dirty, efficiency goes down significantly. It does make a huge difference. And when you're cleaning your fence, please be safe. If you give that power washing job to one of the younger family members, please guide them. I mean, electrocution doesn't happen that often, but it is a safety concern, right? So if you have circulation fans, those basket fans, make sure you tilt them toward the stalls. So at the beginning they are like that, but by time they move, and then if you're not checking regularly, they may be heading to just somewhere else. So make sure they are pushing air toward the stalls. And then please check the air inlet size if you have enough air inlet. If you don't have enough air inlet, you may want to keep your garage door open. It will bring a lot of fresh air, but it will help, but also it will help with the fence to work more efficiently. Okay. And then I think the last question is, do I need to know all this stuff, right? So planting season is coming, and we covered a lot of, calculations, calculators, websites, efficiencies, tables. So no, you don't need to know all this stuff. Please know that tools are available and help is available. You can just reach out to us anytime. So my email address is easy. If you know my name, you know my email address is neslid@visc.edu, or you can just call me so I can come and help and make the calculations for you while you are busy with your planting season. That's also a possibility. Yeah. And with that, I want to open it up to questions.
Well, Nestle, I would say you did a fabulous job. Thank you for the summary. And I was going to ask, how on earth are we going to remember all of this? And you answered that question. I would also add to those who are listening, either live or tuning in afterward, that make sure you go back to the PDP website to this specific dairy signal episode. Every single slide that Nestle showed and those interactive online tools, you'll be able to visit again. And then you can screenshot all the information you need. But we do encourage you to reach out to Nestle. She's the expert we're working with here. Email her, call her, and ask her the questions that are on your mind. I just had one question, Nestle, and that's pretty straightforward. What are the most common mistakes producers make when it comes to incorporating ventilation systems on their farms?
Mhm. Yeah, it's a very good question. I think it will also be a summary of what we presented today, right? So thank you for the question. So one, the more is not always the better, right? We are talking about efficient and smart design. So we don't have to have many ventilation fans. We just need to make those calculations, right? So we don't have to have the supply fans, exhaust fans, circulation fans, all of them together. Sometimes it is necessary, and I do understand. But sometimes even natural ventilation works just fine. So then that is okay, right? We don't have to buy more and more fans. So please be aware of that one. That is one. Another one is maybe it is the last thing we want to do. We are very busy, and I do understand. I can relate to that, but we need to keep these fans clean. If we don't wash them even for 3 months, they will look like you never washed them, right? So please, now summer is coming, it's warming up, it's time to maintain and clean up these fans. And for the circulation fans, basket fans, please check them. So whenever we visit, we see basket fans are heading somewhere else, right? They're not pushing air toward the stalls. It's just a matter of tilting them a little bit. So they do help a lot, right? Basket fans. And then, as I said, air inlet. Usually we don't have enough air inlet. We install these big fans and they are working and trying to pull air, but there isn't enough opening. So it is increasing static pressure and reducing the fan efficiency. So you may need to keep your garage door open. So we don't want to keep the garage door open in general since it feels like more secure if we close our door and it's more contained. But we may need to keep our garage door open if we don't have enough air inlet. Mhm.
Thank you, Nestle. Again, so much information, good information we need to know. So if you've got questions that we've already covered on this episode, make sure to visit the website, pdpw.org, and scroll to our Dairy Signal page to find this episode. It should be uploaded within the hour. And again, call or email Nestle to get in touch with her directly. She's a wealth of information. Thank you so much, Nestle. We appreciate your time with us today on this critical topic.
Thank you for
And
having me. Yeah.
before I officially sign out, I just want to make sure that everybody who's listening today knows about our PDP Smart Workshop. It's a program we're going to be facilitating tomorrow and Thursday. However, the workshop we're going to be facilitating tomorrow in Chippewa Falls is sold out. So if you're interested in learning more about how to use all the data that you're collecting on your farm and incorporating artificial intelligence with that, if you're interested in a hands-on computer lab style workshop, we still have a few seats left for our Thursday, April 16 program. That's going to be happening in Manitowoc, Wisconsin. For more details on that program, once again, go to our website, pdpw.org, and then click on upcoming programs to learn more about that program. So, but hurry, it might fill up. It might already be filled up within this last hour. So thank you, everybody, for tuning in today. If you're wanting your DACE continuing education credits, remember to take the quiz, answer the questions, hit submit. We'll make sure to get you the credits you've earned. And one final thank you to you, Nestle Octanez from UW-Madison. We sure appreciate your time.
Thank you so much. Yep.